Hey there, and welcome back to the ranch. Today I want to talk about the dies for my Clay Spencer tire hammer. When I got the hammer, or when I made the hammer, I went ahead and ordered a 24-inch long piece of 4140, cut, the appropriate size, inch and a half tall by 2 inches wide. And of course, I cut two 3-inch pieces off to make the dies, the original dies for the hammer. And they're just rectangular. They're not arched or combo dies or anything like that. So they're just flat dies with the corners rounded over. And what I was finding was, of course, adding tools makes it all that more functional, such as, this is a 5-degree angle. That is absolutely amazing for putting a nice little flat on the end of round bar and square bar. I have this one, which is 5, 10, and 15 degrees, kind of the similar thing, but slightly different purposes. And then this one was a nice addition. This one, I think, is 10 degrees, but this flat allows me to kind of, when it flares out, I can put it here sideways and stomp it back down to, I think it's 5/16 or something like that. And that worked really good for making shower curtain hooks. Anyways, as you can see, there's a dovetail on the end of all these. I've got a couple other tools that I added this dovetail base plate to. I think like my spring fuller for round stock and everything. I have this on there and a couple others. But originally, I came up with this system. It was a click-and-place system. It was a real quick thing. It just slid in, clicked in place on those holes with these little spring-loaded ball bearings and everything. And while it does work, it is a lot more cumbersome than I expected, because the actual frame to the thing has to be bolted on. I slide it down and bolt it on and make sure it's lined up right and everything. And then I can't leave it on because I lose all this real estate on the sides, and I use the full die. If I come in this way, that piece of metal here kind of blocks how close I can get, and then the piece of metal on this end, which has the bolts running through it, keeps me from being able to come in from the side. So it was really kind of cumbersome, and I wanted something a little bit more useful. So I started by cutting up that rest of that 4140. I ended up getting 5 full-size dies out of it. And you see 3 because one is the oddball. I was going to take this and actually make a couple holes in it and then make, run, let's say this is the new die. I was going to drill a couple holes in the side and have it, so I just put a couple slots in here where it would slide in and then lock down, and I could tighten the bolt and have it lock in place. And then when I take it out, I can either take the bolts out, or if I put them on the back side, they're not in my way at all. But then I got to thinking, besides wanting a better tool mount, and yes, I know I could simply make that little clamp or the frame and all that stuff. I just don't think that these are really big enough to make full use of that. So I had seen a Facebook post a while back where someone had made an oversized bottom die, and if you look, you can see the pencil marks there. That's the regular die. So when I mount this on the tire hammer, the top die is going to come down like that. That gives me a bit of a shelf on the front and back. That should allow me to do, slightly different things. I still have the side to come in if I want to fully squish something from both sides equally and that kind of stuff. But it also allows me to do the thing I was talking about before with the 2 bolts. With this, put a slot running this way and another one running this way, and just slide it in, run it down, and then just give the bolts a quick tighten, and then same thing, taking off. And that way I don't have anything in the way. I have a flat top. This system, I think, will allow me to easily make height gauge blocks, stop blocks. I had tried something for stop blocks with this, and it didn't work out, mainly because I was using soft steel, which was just an experiment, so I didn't want to get into wasting a whole bunch of hard steel. But the soft steel just really deformed and crushed and everything the way you would hope it wouldn't. It wasn't very durable, and even though it was not working out with the soft steel, it presented a lot of errors in the design flaws in my concept that simply weren't going to work, even if I had made the stop blocks out of better material. So I'm going to this. I have a whole bunch of this 1/4 inch thick 1x1 angle. I can modify, I can run the slots in them on the milling machine, and I can make as many various tools as I want. All I have to do is just kind of weld it on the top there, and it would just sit at an angle just like it did with the other system. Anyways, that's what I've got for today, but there's a bonus. Because I had 2 extra blocks, and those of you who were paying attention and counting earlier noticed I was missing 2. These are the 2. I'm making a combo die set. I was originally going to mount the blocks at an angle in the mill and cut straight angles, so I had a very small, short flat that I was going to really round over and all that stuff. And that's always tricky. I don't have heavy duty angle vise or a way to really mount anything quite that solid at an angle. And I got to thinking about it, and a 3-inch diameter circle, and this is 1.5 inches, and this is 1.5 inches. So 3-inch diameter circle, if I mount it in the lathe, there you go. So I'm just going to keep chipping away at this until I have this last little sliver right in the center, barely left. And then I'm just going to polish it up and, of course, prep it for mounting to the base plate and all that stuff. Anyways, that's what I have for today. And I will add more to this video and finalize it and send it out when I get more. Talk to you soon. Okay. Second day of working on the new dies for the power hammer, tire hammer. And this is what I've got so far. I am ready to tack weld the first 2 to their bases, respective bases, in preparation for a thorough heating, probably up to 400 degrees or so for a good welding to the base. The heat on the larger chunks of metal just helps the weld adhere better, helps reduce some warpage in the base plate. Even though those are 1/2 inch, yeah, they'll warp if you run a good heavy bead across there. It'll pull it up. So I'm doing my best to try to avoid that. You'll notice on this I've got some bolts in there, and you can kind of just see that I got some kind of goop coming out of there. The reason being is these are threaded blind holes, and they are for when I make my mounts. They'll, like I showed in the last video, they'll slide in and come down. I can just lock that one bolt and have it in place. The problem is when you are hardening a piece of steel and it's got blind holes and threaded holes and all that, there's a good chance you're going to have a stress riser in there because there's a lot of sharp corners and points. And doing some research, it was suggested that I go ahead and use a grade 5 or harder bolt. I had some grade 8s. I stripped the zinc off of it to avoid any problems in the forge and to avoid any outgassing from the heat to causing any problems inside as well. The paste is some anti-seize mixed with some graphite. It called for high temp anti-seize, which I didn't have. I'm just going to run with what I got and keep my fingers crossed. Bonus, if you ever want a material, a paste-like material, that gets into places you've never even thought about touching, this is your stuff. This stuff will show up in places you've never even visited and smear itself around. Yeah, be very careful with that stuff. Maybe even wear gloves if you're that paranoid, but even then, it's going to end up all over you. It's going to end up all over your work surfaces. So be ready to have a damp rag with some kind of like brake cleaner or denatured alcohol or something available to help clean that stuff off. And for clarity, the paste is obviously anti-seize and graphite mixed together, and it is spread onto the threads of the bolt, but it is actually designed to pack the remainder of the blind hole that the bolt can't get, that little conical part where the drill bit reached the bottom of the hole there and finished its job. That's what the paste is for. I packed it in there with this Q-tip. I filled it about halfway up. I ran the bolts in, and I used a wrench to tighten them up until I just hit snug at that last little bit of thread there. The paste was forced out through the slight gaps in the thread and leaves no air pockets inside of the holes. That's how I was advised to try this, and yeah, everything's an experiment if you haven't done it before, so we're going to try it just like that. Also part of this project, of course, is the new die. You can see I got a nice 3-inch radius, 3-inch diameter, 1.5-inch radius round on that. I've got the edges broken up, softened up a little bit. Focus, there we go. I left the top edge deliberately unsurfaced at this time. I'm going to go ahead and tack weld it in place, heat it up, run the full weld all the way around. I'm going to do this one first, and then line up this one second, so I can make sure they're both lined up identical on the holes. And then I can start the heat treating process. After that, I'm going to go ahead and run it through the surface grinder. I have a little tool cutter surface grinder thing, and I'll just skim off the top 1,000th of an inch or so just to give it a really clean surface, and I'll do the other die as well. But that's where I stand today, at least this morning. I'm going to try to get these all welded up and hardened and tempered this afternoon, and I will have more video shortly on that. Okay, here we can see that I have 2 of the dies tack welded to the bases, and now it's time to match up the third of this match set here. Of course, the first thing is to align that and this and the other face, back face, and I did that using my little machinist square just to make sure it was all lined up. Then I had to align the base to this base, so when they go onto the hammer, of course, this one on the actual ram, and then this one on the anvil. I eyeballed it the best I could, used a square to kind of dive that in, and then I drop a drill bit down. You can see it's not binding or anything, and it is in both of the holes. Here, I'll move that over so it doesn't fall out. And I do the same thing on this one to make sure it's not twisted around that hole. So you can see both of them are moving freely. So that tells me that between running the square on this piece, and I had to do it off the edge of the table here, and lining up both edges that way, and then running the drill bits in there, the 1/2-inch drill bits that I use to drill the holes this way, that tells me that this is about as lined up as I'm going to get it. This gives me the alignment I need to go ahead and do the tack welding. And then next step is to heat up all the dies at about 400 degrees and go ahead and fully weld it. So let's go ahead and get that next part going. Okay, here you can see that I've got the combo dies done. I got the big die done as well, and we'll cover that in a moment. These have been heat treated, hardened, cleaned up, tempered, and then taken to the surface grinder to kind of clean up the tops a little bit, you can just see that I left a little bit of a flat in the tops of each die. I'm still hoping that the 3-inch diameter, 1.5-inch radius, is not too sharp of a radius to give some nice subtle drawing out features. Obviously it'll work for really moving metal if I need to draw out something quick, but I haven't had a project to really try it out yet, so I don't know what the characteristics of these are going to be, or how well they're going to draw out, or if they're going to draw out too well. Just had the opportunity to use these combo dies today on a set of stake flippers, and I gotta say, it was absolutely worth making these things. It made such a huge difference in not only the length of time, but in how controlled the drawing out process was. So little upset with myself for not doing this sooner, but definitely happy I did. So if you're on the fence about the dies for your tire hammer, flat dies will definitely get you a long ways down the road, but a set of combo dies will take you the rest of the way. Also managed to get quite a few stop blocks done. The angle is just standard 1-inch by 1-inch, 1/4-inch thick angle iron. There's nothing special about it. It's just standard A36 steel. 1018, I think. I'm not sure. It's just the standard, grade hot roll steel. The actual blocks themselves are made from a piece of railroad track called fish plate. I happened to come across one ethically sourced, so to speak, and I was able to cut it up and use its various oddball shapes to create these stop blocks. You can see that the corners, inside corners, are rounded over. I used a bullnose bit on my milling machine while they were, after they had been annealed, softened up, to create the shapes and to give the rounded inside corners. That's to help prevent cracking in the corners. These things are going to take a lot of heavy hitting, and I didn't want to risk having one crack on me or send shrapnel flying if it did crack. I've got sizes anywhere from 1/4-inch up to 1, with a few cardinal stops in between. It's not every 1/16 of an inch, but it is every 1/8 of an inch with a few 1/16 dimensions thrown into it. And to show you how they fit, we'll step over here to the tire hammer. This is the big die, the oversized die. You can see what I was talking about, how it mounted to the to my anvil top. I know if you have an 8-inch round anvil and you didn't have a top on it, excuse me, that it may be a little difficult to put those holes in. You'd have to basically disassemble the hammer, and even then, I don't know if you could get a magnetic drill underneath the ram guide here. But this is what I had to work with, so I was able to make it happen. To make that work, you just simply slide it down and lock it in. All I need to do is run this Allen bolt, this one Allen bolt in nice and tight, and that's not going anywhere. That's in there. And of course the opposite is true. Just loosen it up and slide it off. These are just standard shoulder bolts. They are a pretty high grade of steel. They're pretty tough, like grade 8 or something. I had to make these little brass shoulders because short of special ordering shoulder bolts with the exact size I needed, they weren't available. So I went ahead and just got some regular ones from Ace Hardware and made the little brass washers, so to speak. To there's a little bit of an angle inside taper, so to speak, that helps everything just kind of flow and lock in easily. And then it keeps it spaced out enough so that in this bolt is completely tight already, and this just gives it just a little bit, so there's just a little bit of wiggle, just enough to get it on and off. This washer on this side is actually a little bit oversized, so that when the bolt finally bottoms out, it's bottoming out on the washer on the inside of the angle here, and that's the mechanism that locks it in place. The bonus to all this is a double-sided mechanism. I can do this on either side. The drawback for some people for this particular mechanism is that the machining of the angle iron to fit like it does, and of course getting the bolts in the right place is critical. With a machine shop, it's not too hard. You can get everything down to a thousandth of an inch pretty easily and make it work. By hand, it's going to be a little bit tougher. You're going to have to be really, really careful with center punching and even spot drilling to make sure your drill bits are lined up and everything. In the mill, it was easy because, I set up coordinates on the exact center of the block while it was sideways in the vise, and ran off a center, and I went over X this way and X this way, and made it exactly the same dimensions on both sides. And as such, the slots in the angle iron are matched to a degree, but they are designed to be a little bit loose fitting, and that is so when I put it in, it actually sits flush on the die. There's a little bit of give there, and that allows me to make sure that the bottom of the stop block is on the actual top of the die and flush with it, parallel with it. It's going to prevent a lot of problems and damage and issues in the future. Anyways, that's the die blocks for my tire hammer, and I hope this gives somebody some ideas, and hope it helps you improve your tooling situation. Thanks again, and we will see you next time. Have a good day.